The first step in solving a series parallel circuit is to write down the characteristics of a series circuit and a parallel circuit. The next step is to identify the series and parallel relationship. These two resistors are in parallel, but this branch is in series with this resistor. The next step is to simplify it to a simple series circuit. We can redraw it with the one resistor, and we'll call that resistor R1, 2. Before we go too far, we should write down our known variables in this circuit. So here we have 100 volts, and R1 is 10 ohms, R2 is 20 ohms, and R3 is 30 ohms. This is going to help us identify that, hey, this resistor hasn't changed, so it's still 30 ohms. The voltage source hasn't changed, that's still 100 volts. We know R1, 2 has changed, but we can solve that because we can use the product over the sum method here to solve that. So let's do that. So R1, 2 equals 10 ohms times 20 ohms divided by 10 ohms plus 20 ohms. And we know that equals 200 ohms divided by 30 ohms. And that should equal 6.67 ohms. Great. So now we can add that in. 6.67 ohms. Which is different from the 10 ohm and 20 ohm. Remember, we took the two in parallel and made one series resistance out of it. Next, we could take these two resistors and find the total resistance using characteristics of a DC series circuit. So that should equal 36.67 ohms. Now using Ohm's law, we can find the total current of this circuit, which is 2.72 amps. So we'll have at I1, 2 we'll have 2.72 amps, and at I3 we'll have 2.72 amps. Now we should be able to find the voltage at V3 using Ohm's law, which is 81.6 volts, and we know that V1, 2 using Ohm's law is 18.14 volts. Great, now we can transfer that back over here. 2.72 amps at V3 and 81.6 at V3 and 2.72 amps at I3. And we know here we're 2.72 amps, and our total resistance is 36.67 ohms. And we know that characteristics of a DC circuit says that the total voltage, which is 18.14, is equal at V1 at V2. So we can enter that in. 18.14 volts here and 18.14 volts there. Now, using Ohm's law, we can figure out that I1 is 1.81 amps and I2 is 0.91 amps. Let me rewrite that over here. 0.91 amps. Great, now we've completed the whole circuit. Now we can verify this. The 1.81 amps plus 0.91 amps should add up to 2.72 amps. So just because current divides, if it divides here and a little bit of current or more current comes up here and some current comes down there, it's going to meet up again here to equal again 2.72 amps. Likewise, our voltage drops here, the voltage drop across this resistor and this resistor should equal the total voltage at the source.